Hey, we have a video here on the converse of the Pythagorean theorem, and most of you know the Pythagorean theorem to be, if you have a right triangle, a squared plus b squared is equal to c squared. Well, the converse of the Pythagorean theorem doesn't like this c squared to be there. It likes c squared to be right here. And I'll show you why. The converse of the Pythagorean theorem will let you know what type of triangle you have. If you're given the three sides of a triangle, it lets you know whether it's the right, acute, or obtuse triangle just by giving those three sides. Well, how does it do that? Well, if you look here, it says if, and using those three sides, c squared is equal to a squared plus b squared, then it's a right triangle. Remember, c is always the hypotenuse, which is the longest side of a triangle. The second one, if c squared is less than a squared plus b squared, then the triangle is acute. And I like to have it like this, c squared on the left, because if we have c squared is less than, well, what type of angles make an acute angle? Well, angles that are less than 90 degrees, right? So I kind of relate these two together. If c squared is less than, then it's going to be acute. That's the reason why it's helpful to have c squared on the left side. And the same thing here. If c squared is greater than a squared plus b squared, then the triangle is obtuse. This greater than, what type of angles are obtuse? Angles that are greater than 90. I kind of relate that together there. You might need to pause and write this down. I'm moving on to the next slide, and we're going to work some of these out. Determine if the side lengths given make a triangle, and if so, state whether it is obtuse, acute, or right. Well, in order to determine if it makes a triangle, you need to take and make sure that those two add up and are greater than 12. You need to make sure 5 plus 10 is greater than 12. And that is true. So we know it makes a triangle. I mean, we could check the other ones. 10 plus 12 we know is going to be greater than 5, and which other side have we not put together? 5 and 12. 5 plus 12 is greater than 10. We know all those to be true. Basically, I'm only going to be checking the two smallest sides compared to the larger side. All right, so right off the bat, we know we have a triangle. We know that they can form a triangle. So now, since they can form a triangle, what type of triangle will it form? Well, c squared, we know 12 is the longest side, so it's potentially the hypotenuse. And we don't know what to put here, but then we have a squared plus b squared. And work that out, you get 125. What is 12 squared? 12 squared is 144. And so 144 compared to 125, it is greater than. So therefore, it is obtuse. It's an obtuse triangle. Okay, looking here, determine if the side lengths given make a triangle. So first off, take the two smaller ones, 2 plus 13, and it's supposed to be greater than 15. And is that the case? It is not greater than 15. So this right here, those three side lengths do not make a triangle. So you can't determine whether it's obtuse, acute, or right because they don't make a triangle. Alrighty, man. Moving right along. Determine if the side lengths given make a triangle, and if so, state whether it's obtuse, acute, or right. Well, check the two smaller sides compared to the larger side. 6 is greater than 5.5. Okay, so we're good to go. Now, let's go ahead and plug it in. C squared, and we're going to compare it to a squared plus b squared. So if we look here, 2 squared is 4, 4 squared is 16, and that makes 20. Now what about 5.5 squared? 5.5 squared? And we have add these up. We have 1 decimal place, we have 2 decimal places. 1, 2 decimal places. So what do you know about 30 and 25 hundredths compared to 20? It is greater than. And once again, we have an obtuse triangle. You might be asking, can we have it right or an acute, since we haven't had any of those for examples? 9 plus 12. 9 plus 12, is that greater than 15? Yes, it is. So we know that it will make a triangle. Now what type of triangle? 15 squared. We're going to compare it to 9 squared plus 12 squared. 9 squared is 81. 12 squared is 144. 81 plus 144 is 225. And 15 squared, 225. Let's compare those. There we go. That's the one. 225 is equal to 225. That means it is a right triangle. You should have recognized this as a Pythagorean triple because it is 3, 4, 5, and you multiply everything by 3 to get 9, 12, and 15. And one last one here. Yeah, I guess not. So, this is what we have. This is the converse of the Pythagorean theorem. If you have any questions, make sure you ask those the next time you see me, and we will get those answered. Thanks for stopping by.